Hello everybody, welcome into another lesson. So today we are moving into another unit which will be the area of plane figures, or areas of figures in two-dimensional space. This will prepare us for the next unit, which will be surface area and volume of three-dimensional figures, or figures in space. So today it's going to be real simple. We have the areas of squares, rectangles, and then odd shapes, which we'll talk about some postulates for those in just a minute. But first, of course, you have the area of a square, which you're all probably very familiar with by now. If you want to find the area of a square, well, squares have all four sides have the exact same length. So to find the area of a square, you just take one side, set it equal to the second power. That's the area of a square. It's really quite simple for the area of a square. Alright. Then we're going to talk about the area of a rectangle. So let's see. Let me write down the formula. Alright, so to find the area of a rectangle, you just multiply the length of the base times the length of the height. I'm sure you've heard it said length times width, which is also correct, but I'm trying to get us into a little bit more advanced terminology. Length times width is still correct. That's not wrong to say, but it's also referred to as base times height to be more precise. Now we'll do some exercises for those, and then I got some other exercises we'll do. So first here, we're going to be given a rectangle and we got to solve for some missing values. So let me draw the rectangle. So there's your rectangle. Base has a length of 9 centimeters. The height has a length of 4 centimeters. There are two things they're going to ask us to find. They want us to find the area and perimeter, which is abbreviated lowercase p. So we could find the area, which is abbreviated uppercase A, and the perimeter, which is lowercase p. Let's go ahead and solve for the area. The area just equals what? The base times the height, right? So the base has a length of 9 centimeters. The height has a length of 4 centimeters, which 9 times 4 is what? That's 36. Now centimeters times centimeters, that's actually going to give you square centimeters. So whenever you talk about area, your unit should be squared. So the area of this particular rectangle is going to be 36 square centimeters, or 36 centimeters squared. The area, of course, is the total coverage of the shape. Like if you were wanting to carpet a room or paint a wall or something like that, you would need to cover it over area. Then there's the perimeter, which everyone should be familiar with. The perimeter is simply the distance around the shape on the outside. So if you're looking to put up a fence, you might look at the perimeter of your yard as opposed to the area. So what we got now, to find the perimeter of a rectangle, you just add up the length of all the sides. The perimeter is going to be equal to, alright, so what do we know about rectangles? That both pairs of opposite sides are congruent to each other. So you could take 2 times 9 centimeters, because this side and this side are both 9 centimeters, plus you could take 2 times 4 centimeters, because this side and this side are both 4 centimeters. So if you do that, you'll end up getting 18 centimeters plus 8 centimeters, which would mean then that the perimeter is equal to 26 centimeters. So you should get an area of 36 square centimeters and a perimeter of 26 centimeters. So perimeter is always in centimeters or your unit to the first degree. Area is always in your unit to the second degree. And I got some more examples here of all this. There's even going to be a little bit of algebra with this today. So let's see what we got next. Alright, we don't know the height this time. We know the length of the base. So the length of the base is going to be what? At 40 centimeters. The length of the height we don't know. Well, we don't know the area. So we need to find the height and the area. Find H and capital A for the area. They give you that the perimeter P equals 100 centimeters. So it's a little bit of backwards logic this time. We had that the perimeter of this rectangle is 100 centimeters, and then we have the base has a length of 40 centimeters, but we don't know the height and we don't know the area. Well, I'm going to say to solve for the height, since we don't know the area, we're going to base it off the perimeter, right? In order to find that perimeter of 100 centimeters, which we'll set that 100 centimeters equal to what? Well, again, in a rectangle, both pairs of opposite sides are congruent. So this length here of this height would also be h. So you would take 2 times your height, plus then you would take 2 times your 40 centimeters, because both pairs of opposite sides are congruent, and the top base would also be 40 centimeters. So if you simplify this, you'll get 2h plus 80 centimeters is equal to 100 centimeters, which then means that 2h would equal 20 centimeters, which would just mean that the height itself, h, is equal to 10 centimeters. So now we have found the height to be 10 centimeters. So since we now know the height, we can actually go ahead and solve for the area. The area is nothing more than the length of the base, which in this case is 40 centimeters, times the height, 10 centimeters, which then means that the area, let's see, 40 times 10 is 400, and then centimeters times centimeters is square centimeters. So the area of this rectangle would be 400 square centimeters after finding the height to be 10 centimeters. All right. See what we get next here. So this time we have a base length of 16 centimeters. We also don't know the height or the area, so we need to find the height and the area. They give us that the perimeter in this case is equal to 42 centimeters. So again, we need to find the height and the area ultimately. So, first things first, I'm going to say we need to find the height, which means we need to base this off the perimeter. So, we'll take that perimeter of 42 centimeters. We'll set that equal to twice the height because of the opposite sides being congruent, plus twice the 16 centimeters since opposite sides are congruent, which would simplify into 2h plus 32 centimeters is equal to 42 centimeters, which would then turn into twice the height is equal to 10 centimeters, which would have to mean then that the height itself is equal to 5 centimeters. So the height of this rectangle is now 5 centimeters. The length of the base is 16 centimeters. Since we know the height now, we can find the area. The area equals the length of the base, which in this case is 16 centimeters, times the length of the height, which would be 5 centimeters, which would then just give you your answer being 80 square centimeters. So the area of this rectangle is going to be 80 square centimeters after you find a height of 5 centimeters. All right. Let's see what they give us this time. You have a base length of x plus 5. You have a height of x. We need to find the area and the perimeter. So we have a little bit of algebra. Well, let's start with the area. Area equals the length of the base, which would be x plus 5, times the length of the height, which would be times x. And all we're going to be able to do is simplify this in terms of x. We're not going to be able to actually get a numerical value since all we have are variables. So the area, if you do the distributive property, would give you x squared plus 5x. So the area of this rectangle is therefore equal to x squared plus 5x. Now we need to find the perimeter. The perimeter, again, you're going to take 2 times the x plus 5s because both pairs of opposite sides are congruent. You'll take that plus 2 times the x because both pairs of opposite sides are congruent. Which you do the distributive property, you'd end up getting 2x plus 10 plus another 2x, which means your perimeter would have to equal 4x plus 10. So you end up getting the area of this rectangle being x squared plus 5x. The perimeter is 4x plus 10. All right. So another one here where you have the base of this rectangle has a length of a plus 3, the height has a length of a minus 3. We need to find the area and the perimeter. So let's start with the area. The area equals the length of the base, which would be a plus 3, that quantity times the length of the height, which would be a minus 3, which, as we know, this will become a perfect square binomial. So the area would end up being a squared minus 9, since it's a perfect square binomial. So the area of this rectangle is a squared minus 9. Now we just need to find the perimeter, which is equal to 2 times the a plus 3 side, plus 2 times the a minus 3 side, which will do all our distributive property. You would end up getting 2a plus 6 plus 2a minus 6, which when you simplify this, the perimeter is going to be nothing more than 4a. So the perimeter of this square is going to be 4a. The area is a squared minus 9. I think we have 3 more for these, then we move on to the next exercises. All right, so the base has a length of k plus 7. We don't know the height. So we need to solve for the height for sure. We also need to find the area. They give you in this case that the perimeter is equal to 4k plus 20. So what you get then is you have a base of k plus 7. You don't know the height, which that's one of the things you got to find. And you also got to find the area, but your perimeter is 4k plus 20. Well, like the other problems, I would suggest we find the height, in this case in terms of k, which means we need to take our perimeter. So the perimeter, of course, is 4k plus 20. That's going to equal, of course, 2 times the height plus 2 times the quantity of k plus 7, which would turn this into 2h plus 2k plus 14. All that would be set equal to 4k plus 20. Which would then give you, if you simplified this, you would get 2h on the left-hand side would be equal to 2k plus 6 on the right-hand side. Now you can divide both sides by 2. You get the height is equal to k plus 3. So the height has a length of k plus 3. So now that we've solved for the height, we can absolutely find the area. So the area, of course, is equal to the length of the base, which would be k plus 7, times the length of the height, which would be k plus 3. So we'll FOIL this out. You'll get k squared plus 3k plus 7k plus 21. So all that means now is that your area is equal to k squared plus 10k plus 21. So for this rectangle, you get an area of k squared plus 10k plus 21 after you find the height to be k plus 3. 2 more problems with this rectangle, then we move on to some other types of exercises, which I think will also be very good. What do we got here? All right, let's see. Base has a length of x. We don't know the height. So the height will definitely be one of the things we got to find. They actually give us the area for once. The area is going to be equal to x squared minus 3x. So then we also need to find the perimeter. We need to find the height and the perimeter. Well, before we can find the perimeter, we certainly need to find the height. In this case, the only thing they give us is the area. So in order to find the height, we need to take that area, which is x squared minus 3x, set that equal to the length of the base times the height, which would just end up being hx. Now, if we take this a step further, hx equals what? We can factor out a common x on the left-hand side. That would just give you x times x minus 3, which then to find the height would be equal to what? You divide both sides by x, it would just be x minus 3. So we found the length of the height to be x minus 3. Then we have the length of the base to be x. Now it's easy to find the perimeter. The perimeter, you'll just take 2 times the length of the base, so that would be 2x, plus 2 times the length of the height, so that would be 2 times the quantity of x minus 3, which would give you 2x plus 2x minus 6. So that means the perimeter is going to be equal to 4x minus 6. So after finding a height of x minus 3, you get a perimeter of 4x minus 6. One more exercise with this rectangle, then we move on to other stuff in this lesson. All right, let's see what we got here. This time they give us the height to be y. We don't know the base for once, so we got to find the base. What else do they give us? They give us that the area is equal to y squared plus 7y. We also got to find the perimeter then. So we know the length of the height to be y. We don't know the length of the base. We do know the area. So we need to find the length of the base and the perimeter. Well, before you could go anywhere with finding the perimeter, you need to find the length of that base in terms of y, which is going to involve the area. So you'll take that area of y squared plus 7y, set that equal to your base times the height, which would be, of course, by, because it's base times your height, which has a length of y. Well, that's going to give you by equals what? Don't we have a common factor on the left-hand side? We can factor out a common y, which will give you y times y plus 7. Which now we can divide both sides by y. You get the length of your base to simply be y plus 7. So we found the length of the base of this rectangle to be y plus 7. Now we need to find the perimeter, which the perimeter, of course, is equal to twice the length of your base, which is y plus 7, plus twice the length of your height, which would just be 2 times y, this will turn into 2y plus 14 plus 2y, which means the perimeter of this rectangle is going to have to be 4y plus 14. So you find the perimeter of this rectangle to be 4y plus 14 after you find the length of the base to be y plus 7. All right. I got 2 other postulates today that are going to help us, but they're really short. All right, so first thing we have is called the Area Congruence Postulate. All right. This states that if 2 figures are congruent, then they have the same area. So the area congruence postulate states that if 2 figures are congruent, then they have the same area, right? That makes sense because what do congruent figures have? All their side lengths are the exact same. So you're multiplying the base and the height, you're going to get, of both, if they're both the same, you're going to get the same area. I don't think I need to explain that one too much because that's just kind of a common sense postulate. Now there's another one here, and I am going to illustrate the next one because it's going to tie directly into what we're about to do. This next one is called the Area Addition Postulate. All right, let me quote it exactly here. Big word here. Nope, see, I already can't draw. All right. So now we have the area addition postulate. This states that the area of a region is the sum of the areas of its non-overlapping parts. So take a look at this figure I drew right here, okay? I have one weird looking shape here, don't I? But what I can do, remember, we can use auxiliary lines even in doing this stuff for these applications to split these into shapes that we can actually work with and find the area of each region separately. So what you would do, of course, find the area of the first region, then find the area of the second region, and then you would get the total area. So in this case, the total area equals the area of 1, which I'll just put as Roman numeral 1, plus the area of Roman numeral 2. So that's also a pretty straightforward postulate. And it's something that's actually going to help you quite a bit here with the exercises we have coming up in this lesson even. Alright, so that's all the postulates and formulas for today. Now let's put some stuff into practice. Let's see what we're going to do here for the You know what? I'm not going to do that one. It's not that I can't do it, but it almost goes against my beliefs. The symbol I'm about to draw, I don't want to draw it. So I hope you don't blame me too much. Alright, so we're going to have some fun here. We are going to find the area of this figure. So let's see, this has a length of 2. This step has a length of 2.8, so it looks like we're finding the area of a staircase, doesn't it? This has a length of 2. This has a length of 2.8. This has a length of 2. This stair has a length of 2.8. This has a length of 2. And then the stair up here also has a length of 2.8. So we need to find the area of this figure. Well, how in God's name are we going to approach that? Okay, let's take a look here. Let's take a look at this here. So what we need to do is we need to set up some auxiliary lines and separate these regions. So what I would recommend doing is form separate rectangles. 1, 2, 3, 4. Split this into 4 separate rectangles, okay? So let's draw some auxiliary lines here. I'll dot them green. I'll call this region 1. I'll dot this one here. I'll call this region 2. Dot up here. I'll call this region 3. And then this here, of course, would be region 4. Okay, so we have split this staircase into 4 separate regions. So we need to find the area now of each individual rectangle. Let's start with the first rectangle, right? It's region 1. Notice that each of these steps is 2.8 across, right? To get the length of this whole rectangle here, you're just going to take 4 times 2.8, aren't you? Because that would be the length of the whole top of this rectangle in region 1. So 4 times 2.8 would give you 11.2. I'm going to write 11.2 here, okay? Now, we can find the area of region 1, which I'm just going to leave abbreviated as region 1. The area of that, of course, is equal to the length of the base of 11.2 times 2. What is 11.2 times 2? That's going to be 22.4. So now we have an area of 22.4 for the first region. Alright, now it's time for the second region. The second region, in order to find the length of this base here of the second rectangle, we need to take, of course, the length of that would be 3 times 2.8, right? It'd be the length of 3 times 2.8 if you were to add those up for the top part. So what is 3 times 2.8? That would give you 8.4. So this segment here is 8.4. Now you can find the area of region 2. Because you have the length of the base, which is 8.4, times the height, which is 2. What is 8.4 times 2? That's just going to be 16.8. And no, it doesn't give actual units. It just gives the numbers. Okay. So now we have found the region. We have found the areas of regions 1 and 2. So what about region 3? Well, to find this base, you're just going to take 2.8 times 2, which I can tell you is 5.6. So now we can proceed to find the area of region 3, which is going to be equal to the length of the base, which is 5.6, times your height of 2, which what is 5.6 times 2? That's 11.2. So the area of region 3 is going to be 11.2. Now we can easily find region 4. It's clear that the base of region 4 has a length of 2.8. You're just going to take 2.8 times the height of 2, which would give you what? 5.6. So now we've identified the area of all 4 subregions of this staircase. Now we can find the total area, which is simply going to be the sum of all 4 areas together. So that's going to be 22.4 for the first area plus 16.8 for the second area plus 11.2 for the third area plus 5.6 for the fourth area. It's just a matter now of solving the addition and you got your area. So let's go ahead and add all these up. 22.4 plus 16.8 plus 11.2 plus 5.6. Area would be equal to 56 square units. So the area equals 56 in this case. It would be 56 square units when you add all those regions together. That's the area addition postulate at work for you. Okay, what's next? Good one. Just for good measure, I'll even denote right angles. Alright, so what we have here is we have, of course, a rectangle split into 2 right triangles, right? Well, we have the length of the diagonal of the rectangle, which is the hypotenuse of both right triangles. Now, of course, we just need to find the height. We need to find the height of that, which that's going to be used actually solving Pythagorean theorems. So let's call this height h. So let's set up our Pythagorean theorem. Let's take that h squared plus the 8 squared. That's going to equal the hypotenuse squared of 10 squared. This gives you h squared plus 64 equals 100, which would then mean h squared equals 36, which would then, of course, gives you that the height is equal to 6. Okay, good. We got the height now. So, we have the height is 6. Well, we have one whole rectangle now. The area is nothing more than what? The area is equal to the base times the height. Area equals the base times the height, which would simply be 8 times 6, which would have to mean that the area is 48, or 48 square units, however you'd like to say that. The area comes out to be 48 square units. I only have a few more exercises. Oh, another good one. All right, I'll even denote that these are rectangles again with putting the right angle symbols. What else do they give us? They give us that this side here is 30 degrees. They also give us that the length of the hypotenuse is 18. We need to find both what? The base and the height. So, in order to solve for the area of this shape, we need to find the base and height of one of the triangles, right? Because this is a rectangle split into two triangles. So we can find those. The hypotenuse is clearly 18. The shorter leg of that right triangle is across in the 30-degree angle. What do we know about 30, 60, 90 triangles? That the length of the shorter leg is half the length of the hypotenuse. So that now gives you a length of 9, which would have to mean what? That this is a 60-degree angle here. That's all that leaves. The length of the longer leg is the square root of 3 times the length of the shorter leg. So the length of your base would be 9 times the square root of 3. Now we can proceed to finding the area of this rectangle. And the area of the rectangle is going to be, of course, the length of the base, which would be 9 times the square root of 3, times the length of the height, which would be 9, which would give you 81 times the square root of 3 units squared. But we want to get a decimal place approximation to the nearest tenth when doing an area. So let's get an approximation here of what is 81 times the square root of 3. What does that look like? 81 times the square root of 3 is about 140.3. So the area of this rectangle is approximately equal to 140.3 square units. Yeah, generally we're not going to leave areas in radical terms. We're actually going to get a decimal place approximation. All right, I have about 4 more exercises here. Bear with me. Another rectangle. Where's the diagonal at this time? It's going this way. Of course, yes, I'm going to denote that these are rectangles, which will split this rectangle into 2 right triangles. They also give us that the length of the hypotenuse is 10. Then they give us an angle of the right triangle being 26 degrees. Ultimately, we want to solve for the area of the rectangle, but we don't know either the base or the height of this rectangle, which are the legs of this right triangle. So what we'll do, like we always do, we'll call, of course, the height here. We'll call the length of the base. Let's go ahead and solve for the base. Well, you know the length of the hypotenuse, right? If you have an adjacent leg and the hypotenuse, what is that? That's the cosine ratio. So you're going to set up your cosine ratio of 26 degrees. That's going to be equal to the adjacent leg, which has a length of b, over the hypotenuse, 10. So that means the length of your base is going to be 10 times the cosine of 26 degrees, which we're going to round the result to the nearest tenth, to the nearest 1 decimal place. So when you do this, make sure your calculators are in degree mode. And let's see. Good, mine's in degree mode. So 10 times the cosine of 26 gives me about 9. Pretty much 9. So my base has a length of approximately 9. Now I just need to find the height. How am I going to find the height? You have the opposite side over the hypotenuse. That's the sine ratio. So you would set up your sine of 26-degree ratio. That's going to be equal to your height of h over 10. And then, of course, the height would be equal to 10 times the sine of 26 degrees, which then will get an approximation to the nearest tenth for the height. So let's do this. Again, make sure your calculator is in degree mode and not in radians. That'd give you about 4.4. So the height is approximately 4.4. Now we can find the area. The area, of course, is the base times the height, which would simply be 9 times 4.4, which would give you an approximate area to the nearest tenth. Let's take 9 times 4.4. 39.6. You get an area for this rectangle of approximately 39.6 square units, which again is an approximation because we had some trig ratios which are hardly ever exact. So that's the area of this rectangle. So yes, we can even use trigonometry to figure these out too. It's kind of cool that we can do that. 3 more exercises, then we're done. And let's do this here. Of course, we have at minimum a rectangle. We have at minimum a rectangle here. They give you that the length of the hypotenuse is 7, and then they give you a 45-degree angle for this rectangle split into 2 right triangles, which, interestingly enough, what is a 45, 45, 90 right triangle? We know that each leg, of course, is congruent to each other in a 45, 45, 90 right triangle. We'll call this length S for a length of a side. If these legs are congruent, you have a quadrilateral, 2 consecutive congruent legs that's got right angles in it. It's actually a square. So this is actually a square. So we can just take one side square. Well, we know that the hypotenuse is the square root of 2 times the length of one of the sides of the right triangle, right? In a 45, 45, 90 right triangle. So that means the side itself would have to equal the length of the hypotenuse, which would be 7, divided by the square root of 2. So, of course now, I'm not even going to worry about rationalizing it, because we can do now, we just take a side to the second power. Area equals that side, which would be 7 times the square root of 2, that whole quantity to the second power. So the area equals exactly 49 over 2, which means the area, if you do a decimal approximation, would be equal to 24.5. So the area is equal to approximately 24.5 square units. All right, 2 more exercises, folks, we're done. These will be back to the area addition postulate. This will be kind of cool, I think. All right, we're going to find the area of a giant letter I. How about that? I think that's actually pretty neat. What do we got here? But we're going to solve in algebraic terms. We're only going to solve in terms of x and y. We're not going to get exact numbers. So this is going to combine some algebra. This whole length of this base here is 8y. The length of this is 2x, the length of that height. Of course, I should mention that all these here are right angles. Everything here is a right angle, if that helps you. So that you'll be basically working with rectangles. This here has a length of 3y. This here has a length of 3y. What else? This has a length of 3y. This has a length of 3y. And then this right here has a length of 4x. So we need to find the area in terms of x and y. Now, what I'm going to suggest is, because you can't find the area all as one, not outright, split this into 3 separate regions. So basically, you're going to split this into 3 separate rectangles with auxiliary lines. So we'll let this here be region 1. This will be region 2. And then this will be region 3. We'll find the area of 3 separate regions, and then we'll come up with the whole area. Okay? Well, the area of region 1 is going to be easy. You have the whole length of the base plus the whole length of the height. So the area of region 1, which I'll just leave as the Roman numeral 1, is going to be equal to the length of the base, which would be 8y times 2x, which would give you what? What is 8y times 2x? That's going to be equal to 16xy. So we found the area of region 1. Let's figure out the area of region 2. So we know that this side here is 3y and 3y. In order to find the length of this height here, or actually this base, the length of this base here for this smaller rectangle is going to be what? It's going to be 2y. We have 2y there now, times 4x. So the area of region 2 is equal to the length of your base, which would be 2y, times the length of your height, which would be 4x, which gives you then that the area of region 2 is going to be 8xy. Now, if you look at this, because in fact this even has a length of 2x, I think we can clearly see we have 2 congruent rectangles between 1 and 3, right? These two are congruent. We can use the area congruence postulate to save ourselves a step and deduce that the area of region 3 equals the area of region 1, which is also 16xy. So now we have each 3 regions separately. The area is going to be equal to the area of region 1, which is 16xy, plus the area of region 2, which is 8xy, plus the area of region 3, which is another 16xy, which then would give you, of course, that the area is equal to 40xy. So the area of this gigantic letter I is equal to 40xy. After you find 3 regions separately. So actually we got to use both the area addition and area congruence postulates, which helped tremendously. See how nice that area congruence postulate is? It saved you a whole going through finding another area. One more problem, then we're done. Alright, this is going to be a bit of a doozy. So what do we have here? I'll just extend it a tad. Okay. This comes up like this, right? Goes out like that. A little bit skinnier here. Yeah, it does bow in, okay. Bows in a little bit like that. Comes up like this. Goes over like that. Comes down like that. And then comes over like this. So that's a really funky shape, isn't it? Well, what do we got here? We have this base is 8y. We have this height is 3y. We're not given this yet. We're given this length here is 2y. This length here is y. This length here is 3y. Ay. This is 2y. Now up top here we have a length of 4y. We need to find the area of this whole mess. Well, what I think we need to do here is we need to separate these regions. So, I'm just thinking of how we're going to split it. How in the world are we going to split this? Definitely, we're going to take this one here as region 1. Sometimes you got to start a little bit here. This will be region 1. So now it just deals with this. I think I got it now. This will be region 2 right here, this small little piece, and then we'll have region 3 here for the big piece. Okay. So we got 3 separate regions. Again, we're going to find the area of each region. Then we're going to add them together. We'll get our answer. So we're going to find all the areas in terms of y. And I should disclose that each of these are right angles here. We have right angles in each of these quadrilateral regions. Okay. So let's start with region 1. If these are all rectangles, that means the length of your base is 4y, the length of your height is 2y. So to find the area of region 1, you'll take the length of your base of 4y times the length of your height of 2y, which will be nothing more than 8y to the second power. So that's region 1. Now what about region 2? Let's really look at this here. You have the length of your base of this little rectangle being 2y. So you'll take the length of your base, which is 2y, times the length of your height, which is y, which would simply give you your area being 2y to the second power. So now we just need to solve for region 3. Find that area. Alright, well, I think it's clear to see that the length of our base is 8y. So take the length of your base, which would be 8y, times the length of your height, which would be 3y, which means the area of region 3 would be 24y squared. Now finding your area is easy. All you got to do is add up the sum of the 3 areas together. So that's going to be 8y squared plus 2y squared plus 24y squared which when you do that, that's going to give you an area of 34y squared. So the area of that whole odd shape is going to be 34y squared. So that's it for finding the areas of squares, rectangles, and odd shapes where you got to split it into separate regions. The next lesson we are going to get into the areas of parallelograms, triangles, and rhombuses. So I hope everyone has a great night. Take care.